Hi friends, welcome to GMK tutorials. In this video, we are going to see how to computing IDFT from DFT. So before going to this topic, first of all, you have to know what is meant by discrete Fourier transform. What is the formula for that? So this is the formula for 2D discrete Fourier transform. 2D discrete Fourier transform means that the function is of two variables, where f of x comma y is a two variable function. So that's why it is called a two-dimensional discrete Fourier transform, where f of u comma v represents the frequency domain representation. Frequency domain representation variables, where f of x comma v is a time domain function, where u and v are the frequency domain variables. Okay, so this is a generalized formula for two-dimensional or 2D discrete Fourier transform forward equation. This is a forward equation. We can also call it a forward transform. Forward transform. At the same time, the inverse discrete Fourier transform is of the form like this. This is a inverse discrete Fourier transform. Inverse discrete Fourier transform, where f of x comma y is nothing but a time domain function, where mn is suppose if you are taking f of x comma y as a image, the size of the image is equal to m cross n, that is nothing but mn, where f of u comma v represents the frequency domain variable. So e power positive for inverse discrete Fourier transform. For inverse discrete Fourier transform, exponential term, exponential is positive. For forward transformation, this exponential part is negative. That is very important. So where x comma y values range from, that means you are calculating from x values from 0 to m minus 1, as well as y values from 0 to m minus 1. So that means u range from 0 to m minus 1, v range from 0 to n minus 1. That is nothing but it starts from 0 to m minus 1. Suppose if you are taking 1 to m, that is a range actually. So then we will start from 0 onwards. The matrix always starts from 0 onwards. So that's why we will take from 0 to m minus 1 is the length of the corresponding range, as well as x and y ranges also. Now our intention is nothing but how to converting from IDFT computing IDFT from DFT. Computing IDFT from DFT. So for that purpose, you have to take the equation of computing the IDFT using the DFT algorithm. So IDFT using DFT algorithm. So IDFT using DFT from DFT algorithm. So computing the IDFT using DFT algorithm. IDFT using DFT algorithm. So here the thing is that just you have to take the corresponding function inverse discrete Fourier transform, inverse 2D IDFT equation. Okay, so 2D IDFT equation. So for that purpose I have to write again. So here f of x comma y is equal to 1 by mn summation u is equal 0 to m minus 1, v is equal 0 to n minus 1, f of u comma v e power. So it is for inverse means that obviously positive term, e power j 2 pi u x by m plus v by, this is one, right? Now take this equation, you have to multiply on both sides by mn. So multiply by mn on both sides, as well as also so taking the complex conjugate and complex conjugate on both sides. So what happens is, at that time, if you are taking this equation, the equation becomes as, so if you are taking the complex conjugate for this equation, so complex conjugate of this equation, if you are multiplying the above equation with mn and complex conjugate, what happens? Obviously, the conjugate of this f of x is nothing but f conjugate of x comma y. So if you are multiplying this complete equation with mn, means that mn is cancelled here. So therefore, you will get only the equation in the form of like this. So this is the equation if you are taking the complex conjugate of above equation. Now, if you are closely observe this one, it is similar to discrete Fourier transform of a 2D formula for f of u comma v. Right? Let us see here. We will observe this equation. So this is a formula, right? So it is also similar to same function. Now f of u comma v value is equal to f of x. Instead of f of x comma y, we have a f conjugate of x comma f conjugate of u comma v, and the remaining terms e power j e power minus j 2 pi into x by m plus v by n, and this is all similar, right? Just only instead of f of x comma we have a f conjugate. That means this is equal to two-dimensional 2D discrete Fourier transform of f conjugate of u comma v, right? So that is important. So this equation is equal to, now this is equal to discrete Fourier transform of 2D DFT, that is nothing but this is equal to 2D DFT of f conjugate of u comma v, right? Now this is a equation. The left side of this equation is equal to this one. That means that mn of f conjugate of f comma v. Suppose if you want to find out the inverse, that means inverse IDFT, that means if you want to find out the f of x comma y, just if you are giving the input as f conjugate of u comma v to the forward equation, you can get the result as if you are giving the input as that means this is the input. If you are giving the input to this forward equation, you will get resultant value is equal to f conjugate of mn, right? So this quantity is, if you know this f conjugate of x comma y come into mn, obviously you can get the f of x comma. This f of x comma y is nothing but inverse discrete Fourier transform. That means if you have any algorithms related to for finding the two-dimensional discrete Fourier transform, if you are applying the input as the f conjugate of u comma v, then you can directly get the f conjugate of x comma y into mn. That value is equal to directly, that means if you are giving the 2D DFT value is equal to f conjugate of x comma y into mn. So if you know the f conjugate of x comma y into mn means, obviously you can find out this value. So how we are going to find out this value? Generally conjugate of f conjugate of x comma y is equal to f of x comma y. Why? Because f of x comma y is nothing but a real value, means complex conjugate is also same value. So if you know the f of x comma y, simply you can multiply that with mn, you can get the corresponding. So result to this is nothing but f of, if you take the complex conjugate and multiply it with a constant value mn, you can get the f of x comma y directly. So that means from this equation we can conclude that if you know the f of u comma v, so the conversion process is very simple. Suppose, so if you are having a f of u comma v, just take the complex conjugate of f of u comma v and take the 2D discrete Fourier transform, 2D DFT, you will get value of f conjugate of x comma y into this value. That means if you are if you have f of u comma v is the value, if you are applying the 2D discrete Fourier transform to this one, you can you can directly find out the f of x comma y. So that is that resultant value in the form of f conjugate of x comma y into mn format. So if you know this equation, you can directly find out the f of x comma y. Take the complex conjugate. So the complex conjugate of this one is equal to f of x comma y. So multiply with the mn value, that gives rise to directly, it gives the mn, that gives the inverse discrete Fourier transform value. Okay, so that is the way we are going to find out the IDFT using the DFT algorithm. So why? Because we are following this approach means generally the procedure is calculating is one dimensional way. So one row is completed, then you will go for the second. That means the 1D transformation takes a lot of time. So for that purpose, if you know the f of u comma v, directly you will take the complex conjugate and apply the discrete Fourier transform algorithm. You can directly get the f of x comma y very easily. So this is the way we are going to calculating. So thank you for watching GMK tutorial. Thank you.